Okay, so if we look at this picture, we can see that for this function, as x gets close to a, as the x value, or if on the x-axis we get close to a, the f of x function gets close to L. So if we have to think about it, if we were in the neighborhood of x equals a, and we were here or here on either side of a, and then we went up onto the function, as I get closer and closer to x equals a, my y gets closer and closer to L. And so we would say the limit as x approaches a of f of x equals L. Limit, I'm going to write that out in words. You can do that or not, up to you. As x approaches a of f of x is equal to L. This is essentially a y value. And so what we're describing is, hey, if I'm on the graph of this function and I get close to a certain x value, that means I'm getting close to a particular y value. And like she showed us with the window in front of the function, even if we don't know exactly what happens when you get to x equals a, even if the function becomes a hole there or jumps to a different point or has a solid point, any of those three situations are still considered to be the same limit, because what we're describing is not what happens when you get there, but what happens when you're very, 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 very close. It's a weird thing to do. It's different than anything we've done before. We're real into the function value, not just sort of like, here's what the function looks like it's doing. Okay. So, if I look at this graph, we're going to throw some arrows on the ends here and put like a hole here. Make this a little bit of put a little bit more interesting things on this graph, just so we get a little bit, these are all things that are kind of implied, just not there. So we've got arrows on the end, we've got sort of a vertical asymptote going on there with my pink line. The end of the left thing probably is an open circle. The limit as x approaches 4, looking at this graph, is equal to 0. If I'm on the f of x graph, heading towards x of 4, would mean that I'd also be going towards a y of 0. Okay. I'm a big, where's my little circle? Oh, here he is. He's up there. Grab him. He's going to be like my car. Okay, I'm all about the little car driving on the function. So if you're driving on the function, oops, you're on the graph of the function and you're driving towards the spot on the function where x is 4, in either direction, you're also driving towards the spot where y equals 0. So the limit as x approaches 4 for this function is 0. All right, yes, no. Good, not good. Good, okay, yeah, I need visual confirmation that we're not completely lost. All right, so this is the one that's always a little upsetting. The limit as x approaches 2 for f of x. That's 3. As you're on this graph, getting closer to x of 2, you're getting closer to y of 3. You know, if we're getting close to the spot where x is 2, we're getting close to a y of 3, even though f of 2 is in fact 5. Now, it's not that we don't care that those don't match up. Like, that actually is something we care about a lot in calculus. It's going to make a big difference for other things that we do. But it's the thing is we don't just care about the function value. We care about the function value and we care about the limit, and we are going to care ultimately if they match. It's going to make a difference in for certain calculus things if these things match and if they don't. But the limit's describing sort of here's what the pattern looks like. If this was sort of a nicely normal graph, this point would 2, 3 would be on the graph. It's wackadoo. It's 2, 5 for some reason. There's a hole right there. The limit's one number, the function value is another. All right. Everyone okay with that? Now, these 3 guys. And there's a, you guys have, no, I fixed it on yours. Okay, so this is, I'll fix it on mine. This is just a 0. So this has, load this up a little bit more. Boom, okay. So now we can see there's a little plus here, there's a little minus here, and then this is supposed to just be a 0. I think it is on yours. This is an older copy. Anybody have any idea what those are for? Any experience with limits? Very good. Yeah, they're direction indicators, right? So a plus means we're approaching from the right. Sometimes this is called a right-hand limit, because if you think about, if you put your hands on the graph, you would be using your right hand, tracing the graph, getting close to 0. So coming from the right side of 0, versus put your hands on the graph, your left, using your left hand, tracing. So you think about your hands on either side of 0, tracing with one hand, tracing with the right hand limit, left hand limit. You can do that with any number, left and right of 4, they actually come together. Left and right of 2, they actually come together. Left and right of 0, you got craziness. All right. So from the right, and because I added that arrow there and that vertical asymptote, it looks like my function's going to keep going up and up and up and up and up. So I would say the limit from the right side is positive infinity. It doesn't really have a limit value. The y just keeps getting bigger. That's basically what saying that the limit is positive infinity means. It just means as x gets close to 0 from the right, my y's are just going to keep getting bigger and bigger and bigger and bigger. All right, what do you think the left limit's going to be? As x approaches 0 from the left side, driving towards x of 0, what's our y? It's 0. So what does that mean for overall limit? Here's our mean girls. The limit does not exist. It does not exist. And the limit did not exist in Mean Girls was a slightly different limit question. But this limit does not exist because when we look at the behavior from the left and the right limits don't match. They're not equal. We don't have the same behaviors going from one side as the other. We had the same thing, left and right of 4 got us the same place. Left and right around 2 got us to the same place. Left and right from 0 don't. If it doesn't specify a side, you should think about both of them. Sometimes, though, we only want to think about one side at a time. So you might be just asked about one side, or overall, generically, you should automatically think about both. Okay, so, and I've got more problems. Actually, this is not exactly what you guys have, but this is the graph you have. So this is the graph. I want you to go ahead and answer the limit questions you have for this particular graph. All right, see what you can do with that.